Hello, welcome to our webinar. Great that you're all attending. My name is Bas van de Bogert. I'm the Director of Business Development within JOA. Today I'm here with two of my colleagues virtually. Martin, who will show you a real-life case using our modeling software, and Eline, who will include images and slides in this webinar to make things more lively and clear. So today we will show you how to prevent operator exposure and improve safety in an industrial environment with our proprietary modeling. First, I will give you a brief introduction of this topic and our approach. Then I will tell you more about our modeling software and what kind of data we need to measure as input for our model. Then, as stated, Martin will show you our modeling software by using a real-life case of one of our clients in the FMCG sector. And then we will close out by addressing one or two of your questions, which lead me to say, please use our chat function. If we receive more questions, please do so. We will collect them all, answer them, and share them with everybody. So the aim is to make this webinar short and powerful. So it will take 15 to 20 minutes maximum. But again, we aim to answer the one or two questions. Why this topic? Well, in practice, we see a lot of sites struggling with possible fine combustible dust, aerosols, and toxic vapors. And it is challenging to protect the operators of exposure and ensure their safety. So what is our approach with these type of problems which arise on sites? Well, we always start with a consultancy study in which we address three possible interconnected directions. So the first solution direction we aim for is the process optimization. We will come on site, we will analyze your specific production process, and we will explore possible improvements to reduce indoor emissions of dust, aerosols, and vapor. Second step we do is we eliminate the source by effective extraction systems. We advise on tailor-made solutions, again, in order to address the dust, aerosols, and vapors. And the third solution direction we aim for is to dilute the source. We do this by cool jets and ventilation, and we do this based on a dilution model and on the possible needed push and pull solutions in regards to the operator exposure and explosion zoning. So these three types of solution directions require advanced data modeling. And we really believe in this approach because it guarantees the process in order to build the system. And it makes it also, therefore, a long-term most economical because we can predict and guarantee personal exposure levels. So beside this, in our 20 years existence, we have implemented over 1,000 systems. We have used this experience in our modeling, and therefore we can also guarantee a first-time right installation and a low-risk implementation. So rather than a trial and error approach, we can predict how the system will work in detail. And last but not least, this makes it also future-proof ready, especially from an upgrade standpoint. With changing legislation around ultra-fine particulates or possible legislation changes on volatile organic compound and future upgrades, this predictive modeling can also optimize capital expenses. So now let's dive in the model and the needed data. So as stated, the model is patented of our own design, and we use the data from the measurements we do on the sites, and we will do that by interviewing, take samples, reviewing situation, and in that way we can model the exact situation in your factory and adjust the system accordingly. So what kind of data we will need and we will require? So we observe the production process and related operator interaction. We measure emissions by personal emission sampling, measure the production room emission sampling. We determine product characteristics. Martin get in a little bit more in detail on this topic. We review the existing extraction and ventilation systems. We review the environmental exposure situation, also the explosion safety, and last but not least, we benchmark the energy usage to identify possible optimization areas. So, all in all, this gives us the possibility to predict different scenarios that could happen in reality on that specific site. So, well, the best way is to show a real-life case. So, again, Martin, can you show us?
Thank you, boss, and thank you all for attending. As already mentioned, we are focusing on 3 interconnected solutions to reduce your indoor emissions. The first one is process optimization. Second one, source elimination. And the third one, source dilution. Today we are focusing on source elimination by effective extraction systems. Here our Gcm modeling tool is used to properly design the systems, securing stable and reliable operation throughout the lifetime. Why is there a need for source elimination? The dark blue line indicates a large source of dust. This source results in high concentrations in the plant, far above allowable concentrations for the operators to work safely without PPEs. In addition, an explosive atmosphere can arise. By removing this source with an effectiveness of 90%, the indoor emissions are reduced tremendously, with as a result that the operators can work without PPEs within allowable dust concentrations. To secure the effectiveness of the systems, a balanced and minimum fouling system is required. Product properties like, for example, particle sizes, hygroscopic behavior, cohesion and adhesion parameters are an important factor to be analyzed during the design phase. The product properties are translated to what we call VO grid. With the VO grid, the minimum, mean and maximum recommended velocities in the systems are determined and used as input for the Gcm modeling. Now you see the Gcm model. At the left side we have the property window where we are inserting all parameters for the different components of the system. In the center of the screen we have the actual model, including the extraction points starting from your process and the piping layout and of course the equipment to clean the gas. And at the right side we have the workflow manager, including customer specific parameters, but for example also items like insulation characteristics and, very important, the VO grid parameters. If we are inserting a system, we always start from your process, which for us means the extraction points. Several of them are shown here, and when we click on one of them, we can insert all the parameters like capacities, humidities, temperatures, and also the hood types, with in the next screen the geometry of the hoods to properly calculate the pressure drops and the air intake at all positions of the system. Next we go to the piping layout. Here you see the grid of the system, which basically is the entire layout of the system. So from the 3D layout we are taking the full model of the system with all the extraction points throughout the plant. Here you see a central system with the equipment on the roof. So all of this is translated into the Gcm model for any pipe section. And at the end of the system we have the equipment. Here we are talking about an explosion safe dedusting system, but this could for example also be a vapor extraction system, We're showing the fan here with, for example, the frequency converter settings to fully model the system and predict what's going to happen when we are taking the system in real life. Now we run a calculation of the system, and what you just saw is that all velocities and static pressures are indicated in the system now throughout the entire system. And the very important topic here are the balancing restrictors. The balancing restrictors ensure that the right capacities are distributed throughout the system. They are of a special shape to ensure that they are minimum fouling and making sure that the system is balanced and running stable throughout a lifetime. Next, we are showing the advanced parameters. Those are all physical parameters included in the system, starting from, for example, humidities, but also the densities, enthalpies, which is crucial if we're talking about energy recovery systems, for example, and all the mass flows of the different components. They're all included in the model. And now, if you would like to have a little bit more insight, we can, for example, also create graphs of the system. Now we're just selecting one position where we will be showing the velocity throughout the system. And what you see here is that the velocities in the different pipe sections are nicely within the critical velocity range. So the blue line indicates the minimum, the red line the maximum, and a little bit further downstream the system we are below the critical velocities, and that's because we are after the dust collector, so all dust is taken out and there is no risk for settlement anymore. In this model we are showing a dedusting system, but the selection possibilities are very broad in terms of, for example, equipment, carousels, but also heat recovery can be included, and drains for systems with high humidity. So we trust this explanation of the Gcm modeling software gives you more insight in how we are balancing our systems, and I would like to give the word back to Bas. Thank you.
Great. Thank you, Martin. Thank you for showing us what modeling is all about within JUA by using a real-life case. I hope for you all it was very informative. Now let's dive into the questions we have received during this webinar. From Graham, he asks, you mentioned process guarantee. What does that mean? That depends on the situation. We mean we can guarantee the levels of emissions to be achieved, which are predefined. Martin showed us, but we can also guarantee potential uptime, even in difficult cases like with hygroscopic products, especially when in case of where it is key to keep the main headers clean. Therefore, it's crucial to model the different scenarios and the potential outcomes to give that guarantee. We have time for one more. Carlo, Martin mentioned balancing. Why? What's the added value? In short, long-term stable operations of the system. Also, as shown by Martin, we use that by using restrictions instead of valves, butterfly valves or gate valves. And the result is no plugging, but also no human interference. And that's, in my words, that makes it dummy-proof. So balancing is key. And also with the previous question, balancing and process are unique selling points what modeling can bring to the table. So let's close out. The other questions we will collect and answer them and share with you all. And I want to thank you for attending this webinar. If you have any questions on operator safety, operator exposure, emissions, exhaust air, please reach out, get in touch with us, and we're happy to help. And we hope to see you on our next webinar. Wish you all the best and have a great day. Bye-bye.